Hi, this is Daryl Lewis-Sandy from Mana. Today we'll be starting the first of our tutorials in a series dedicated to the physical quantity service. The physical quantity service is a GraphQL-based microservice which provides the capability to parse and extract physical quantity mentions from strings, perform unit conversions, and do arithmetic with physical quantities in a dimension-safe way. This series of videos has a Workspace service template that contains all of the lessons that we'll be working through. So let's start by creating a copy of that. I'm going to navigate to the Workspaces tab in the ManaQ portal and scroll down to the public templates and search for physical quantity tutorials. Press the clone button. Now I can give this workspace any name that I want. And after a moment, it will open our copy of the workspace template. This workspace is organized around knowledge graphs dedicated to each lesson. It also comes preloaded with many useful services, including the Mana Loader, the Mana Measurement Service, the Mana Measurement Utility Service, and the Physical Quantity Service. Finally, it comes preloaded with several assistants, which will make working through some of the exercises easier. If you've been following along with your own copy of the workspace, now might be a good time to pause the video and look a little bit more in depth at the kinds and functions and knowledge graphs that are included in this tutorial template. Welcome back. Now that you've had a chance to look around the tutorial workspace, let's dive into the structure of the physical quantity kind. It's good to understand the physical quantity kind because we'll be working with it in detail in the next lessons. Physical quantities are measurements of observable phenomena, for example, the length of a ship, or the speed of an aircraft, or the voltage of a car battery. Every physical quantity has a numeric magnitude and a unit of measure. The purpose of the unit of measure is to provide an agreed-upon scale, which helps us understand just how big the measurement is. The physical quantity kind has three fields. One that's a unique identifier for instances of that kind, and here we've used the surface form for the physical quantity. One that's the numeric magnitude, which is just a floating point number. The last field is the unit of measure, which is an instance of the unit of measure kind. When engineers work with units of measure, they frequently encounter units that have prefixes, like kilograms or centimeters. And they also encounter units that are defined as a ratio or product of other units, like torque is measured in feet-pounds, or velocity is sometimes measured in feet per second. If we look at the unit of measure kind, we can see that it has a unique identifier field, which is the surface form of the unit of measure, and a collection of factors, each of which consists of a simple unit of measure, possibly raised to a power, and sometimes with a unit of measure prefix. Because the unit of measure kind is a symbolic representation of how a unit of measure is constructed, we can do things like automatically put the unit of measure into the simplest form, for example, by canceling like terms when they occur in the numerator and denominator of a ratio. In the unit of measure prefix kind, we have the relation between unit of measure prefix symbols and the corresponding multiplier that's implied by their use. For example, we have all of the unit of measure prefixes from the metric system. If we look, we could see that k corresponds to a multiplier of 1,000. The simple unit of measure kind has the basic building blocks for unit of measure expressions. Each instance of this simple unit of measure kind relates the symbol commonly used for a unit of measure to two key pieces of information: the physical dimension to which that unit of measure belongs, and the conversion factor from that unit of measure to the corresponding SI unit. Conversion factors could be linear or affine functions, which means that you can specify both a multiplier and an offset to the corresponding SI unit. This is useful when you're defining a unit of measure such as temperature, where the 0 on the Fahrenheit scale doesn't agree with 0 on Celsius. The final concept represented here is that of physical dimension. Physical dimensions are categories of units of measure that represent the same kind of observation. We can convert between units of measure that are in the same physical dimension, such as feet, inches, and meters, but we can't convert between measurements that are in different physical dimensions, like inches and hours. This agrees with our intuitive understanding that when we measure length and time, we're measuring two different kinds of things. There are about 70 different physical dimensions that occur in all of scientific literature. And if you scroll through the instances of this kind, you'll find that most of them are represented here. All right, it's time to have a little fun. So now we're going to convert measurements from the monomeasurement kind into physical quantities. And in doing that, we're going to have to reconstruct the unit measure kind, including all of its rich properties, its physical dimension, its unit conversions, its factors, from the monomeasurement kind's unit of measure, which is really just a surface form. So to help us do that, we're going to use the measurement to quantity function that's provided in the monomeasurement utilities service. So let's start by bringing that into our workspace. We're going to drag that function onto our canvas. And then we're going to select that function. We can see that it has two arguments. The first is a measurement, and the second is a dimension name. We'll get to that second argument in a little bit, but for now, let's just try entering in a nice simple measurement. The ID from the monomeasurement kind doesn't matter, but let's give it a magnitude of 1. And let's do a unit of measure of foot. And I'm going to spell it out here as foot instead of using the standard abbreviation. And when we run that, after just a moment, we'll see that not only did it get converted to a physical quantity, but it normalized its representation. So we can see that the foot got converted to FT, the standard symbol for foot, and it expanded the factors. So we can see we've got a single factor, which consists of the base unit of measure, which is foot, which has dimensions of length, and it has a unit conversion of 0.3048 feet per meter, which if you look up the conversion on Wikipedia or Google, you'll find that that's approximately correct. All right, so that looks like it's working. Now let's try something a little more complicated. As I mentioned before, we should be able to simplify the representation of the unit of measure automatically. So here we're going to give it a unit of measure that has unnecessary terms in it. So we'll have foot per foot. Let's do kilogram foot per foot. And when we run that, after just a moment, we see that it simplified it to just kilogram, because foot appears in both the numerator and denominator of the ratio. It's able to cancel them out. And we can see that it's able to infer the correct dimension and the unit of measure conversion from kilogram to gram. Great. All right, let's give it something much harder. Let's try something with mixed units of measure from the imperial and metric system. So let's try ppg, which is a measure of density. It's pounds per gallon per day And just for fun, let's multiply that by kilograms. All right, so this is just a wacky unit of measure here. I don't know what you'd be measuring in those units, but it should be fine. When we run this, we'll see that it expands the units of ppg to pounds per gallon, and we can see that we've got kilograms per day in there as well. So it looks like it's handling that just fine. All right, so I'm going to give you a few moments here to play with it, try some conversions on your own. Go ahead and try crazy units, try things with prefixes and units from the metric and English system. If you need some hints on what units of measure you might want to try, you can always look at the unit of measure kind or the base unit of measure kind for inspiration. I'll be right back. All right, welcome back. I hope you had a fun time playing with the measurement to quantity function. I am going to show you one last thing here before we finish up, and that is what that second argument does. So I'm going to type in a unit of measure, and I'm going to do something a little strange. So I'm going to use pounds of mass times meters per second, and let's spell those out differently in the two different for the two different seconds. All right, so pounds, meters, second per second, and I know that it'll parse that or convert that from. So yeah, we see we've got pounds mass meter per second squared, which is what we'd expected. It combines these seconds into a single term raised to the second power. That's great, but let's say that I want to be certain that this was the right dimension. I know that this is converting it to the right unit of measure, but let's just make sure that the dimension is correct. So the second argument lets us guard against physical quantities that have the wrong dimension. And this is sometimes important when you're interoperating between the monomeasurement kind, which has strongly typed dimensions, and the physical quantity kind, which does not. So let's go ahead and try this out. I'm going to put length in here first. What I would expect to happen is that any measurement that is not of dimension length is going to not get turned into a physical quantity, and instead I'll receive a null. So when we run this, after a moment we could see that it returns null. Okay, that's good. We have successfully guarded against using that input when we require a length. Now this strange unit of measure here, mass length per time, that's actually a force. If we put force in here and run, we would expect that it returns the physical quantity that we previously obtained, and it does. All right, well that's it for this tutorial. I hope you'll join me next time as we look at parsing functions. If you enjoyed this video and want to learn more about the physical quantity service, don't forget to subscribe to the Mana Inc. YouTube channel